In this video, we are going to learn how to solve systems of linear equations using matrices, and we're going to use examples. So, for example, let us have example 1. Solve x plus y plus z is equal to 1, x plus 2y plus 3z is equal to 4, and x plus 3y plus 4z is equal to 6 using matrices. So, the first thing that you're going to do is we are going to rewrite this equation in form of matrices, where the first matrix is going to be that of the coefficients of the variables. So that will be 1, 1, 1, 1, 2, 3, 1, 2, no, 1, 3, then 4. So that is the matrix of the coefficients. Then the other one is the matrix of the unknowns, that is the variables x, y, and z. Then finally we have the one for the results, that is 1, 4, 6. So then we can name this one A, this one X, and this one B, so that the unknown represent that by X. So if we want to get X, you're just going to take divide B by A, that will be like A over 1 over A times B, for just the inverse of A times B. So it means we are going to have to look for the inverse of the coefficient matrix and then multiply that by the result. So to get the inverse of a matrix A, you are going to take 1 over its determinant, then you're going to multiply that by its adjoint. So let us start by obtaining the determinant of A. So in this case, you're going to use the elements in the first row. You're going to take the first element, which is 1, times the small matrix that is left when you cover its row and its column, that is 2, 3, 3, 4. 2, 3, 3, 4. Then we're going to subtract the next element, which is 1. So 1. Then you multiply that by the determinant of the small matrix that is left, that is when you cover the row and the column, you have 1, 3, 1, 4, 1, 3, 1, 4, plus the last element in that row, that is 1. When you cover its row and its column, you're left with 1, 2, 1, 3, 1, 2, 1, 3. So let us work this out. So we have 1 into 2 times 4, that is 8, minus 3 times 3, that is 9, minus 1 into 4 minus 3, plus 1 into 3 minus 2. So we have 1 into negative 1, minus 1 into 1, plus 1 into 1. So we have, that is negative 1, minus 1, plus 1, which is just equal to negative 1. So the determinant of that matrix is negative 1. So the next thing we're going to look for is the adjoint of the matrix A. So for us to obtain the adjoint of that particular matrix, we're going to use the cofactor of each and every element in that particular matrix. So we're going to start with the cofactor. The first element is 1. So 1 is in row 1, column 1, so just take negative 1, then row 1, column 1. Then you multiply by the small matrix that is left there, which is 2, 3, 3, 4. So that will be, this is odd, even, so the negative will disappear. So we have 2 times 4, which is 8, minus 3 times 3, which is 9, and we have that to be negative 1. Then we go to the cofactor of the next element. The element is 1. So 1 is in row 1, column 2, and the small matrix that is left when you cover its own column is 1, 3, 1, 4. So we can work this out. Since this is odd, this negative will hold. So we have negative 1 into 1 times 4, that is 4 minus 3. So that is negative 1. Then the next one that we're going to look for its cofactor is this one here, the third element there, which is also 1. So it is in the first row, the third column. So that is 1 plus 3. And then the small matrix that is left is 1, 2, 1, 3. So since this is even, the negative will disappear. So we're left with 1 times 3 minus 2 times 1. So that is 3 minus 2, which is just 1. Then from there, we are going to look for the cofactor of the next element, which is 1. So 1 is in row 2, column 1. You cover its row and its column, you're left with 1, 1, 3, 4. 1, 1, 3, 4. So this is odd, the negative will hold. So we have 4 minus 3. That is just negative 1. Okay, then let's move to the next one. So the next element that we're going to get its cofactor is 2. So 2 is in row 2, column 2. And when you cover its row and its column, you're left with 1, 1, 1, 4. 1, 1, 1, 4. So you're going to take this, is the power is even, so the negative will disappear. So we have 1 times 4 minus 1. That is 4 minus 1, which is just 3. Then let us go to the cofactor of the next element is 3. So 3 is in the second row, the third column. When you cover its row and its column, you're left with 1, 1, 1, 3. 1, 1, 1, 3. So this is odd, so the negative will hold. So we have 3 minus 1. That is just negative 2. Then you look for the cofactor of the next element. The next element is 1. So 1 is in row 3, column 1. And when you cover its row and its column, you're left with 1, 1, 2, 3. 1, 1, 2, 3. So you can work this out. This is even, so there is no negative. So we have 1 times 3, that is 3 minus 2. So that is 1. And then we go to the cofactor of the next element. And the next element is 3. So 3 is in row 3, column 2. When you cover its row and its column, you're left with 1, 1, 1, 3. 1, 1, 1, 3. So that is, this is odd. So there's a negative there. So 3 minus 1, that is 2. So that is negative 2. So you can get the cofactor of the last element, which is 4. So 4 is in row 3, column 3. So 3 plus 3. And when you cover its row and its column, you're left with 1, 1, 1, 2. 1, 1, 1, 2. So we can work out that the cofactor of 4, so this is even, so it means therefore that we have a positive, so it is just 1 times 2, that is 2 minus 1, which is just 1. So now we have the cofactor of all the elements in that particular matrix. So what we need to do is just take the transpose of that adjoint matrix. So we have the adjoint matrix, which is just negative 1, negative 1, 1, negative 1, negative 1, 1, negative 1, negative 1, and then we have negative 1, 3, negative 2, negative 1, 3, negative 2, then we have 1, negative 2, 1, 1, negative 2, 1. So that is the cofactor matrix, that is the cofactor matrix. So for us to get the adjoint of that particular matrix, we just take the transpose of the cofactor matrix. So that will be negative 1, negative 1, 1, negative 1, 3, negative 2, 1, negative 2, 1. So that is the adjoint of our matrix there. So now we can get the inverse of A is just 1 over the determinant, and found the determinant to be negative 1. So that is 1 over negative 1 times the adjoint, which is negative 1, negative 1, 1, negative 1, 3, negative 2, 1, negative 2, 1. Of which, if you open up, if you multiply by this color, you're going to get 1, 1, negative 1, 1, negative 3, 2, negative 1, 2, negative 1, to be the inverse of the matrix A, that is the coefficient matrix. So now that we have the inverse of the coefficient matrix, we can just multiply that with the result so that we get the unknowns. So we have the unknowns as x, y, and z. And for us to obtain that, we're going to pre-multiply b by the inverse of A, and the inverse of A is here. So we have 1, 1, negative 1. We have 1, negative 3, 2, negative 1, 2, negative 1, times the resultant matrix, which is just 1, 4, 6. So we can multiply this out. So we have 1 times 1, which is just 1, plus 1 times 4, which is just 4, plus negative 1 times 6, that is minus 6. Then the next one, we have 1 times 1, which is just 1, plus negative 3 times 4, which is just negative 12, plus 2 times 6, which is just 12. Then you have negative 1 times 1, which is just negative 1. And we have 2 times 4, which is just 8. Then negative 1 times 6, which is just minus 6. So if we work this out, this is 5 minus 6, which is just negative 1. Then we have 1 minus 12 plus 12, that is 1. Then we have 8 minus 7, which is also just 1. So remember that this was x, y, z. So it means the values that you obtain, and that is x is equal to negative 1, y is equal to 1, and z, this one here, is equal to 1. Example 2, solve 2x minus y plus z is equal to 1, x plus 2y minus z is equal to 4, x minus y plus 2z is equal to 1 using matrices. So let us look at the solution here. So the first step, as we said, is just rewriting these in form of a matrix, in which case you're going to have the coefficient matrix, that is 2, negative 1, 1, 1, 2, negative 1, 1, negative 1, and 2. So that is the coefficient matrix. Then the next matrix is the one for the variables, that is x, y, and z. And then we have the results, that is 1, 4, 1. So for us to be able to do this, we're going to have to label this one as A matrix, this is x, and that is B. And we are going to be looking for this because it is the unknown in this situation. So if we add ax is equal to b, it means x will be b over a, which can be written as a inverse times b. So that's what we're going to look for. We're going to check that x is going to be given by negative the inverse of a times b. So it means we're going to look for the inverse of a, which is obtained by 1 over the determinant of a times the adjoint of a. So we're going to look for the determinant and then the adjoint before we can get the inverse of a, which will later multiply or pre-multiply the right hand side of the equation with. So let us start by obtaining the determinant of a. So the determinant of a is going to be obtained by just considering the first row and the elements in the first row. So we're going to check 2, which is the first element, When you cover that row and that column, you're left with 2, negative 1, negative 1, 2. 2, negative 1, negative 1, 2. Minus the second element, which is negative 1. So when you cover its row and its column, you're left with 1, negative 1, 1, 2, plus the third element, which is just 1. Cover its row and column, you're left with 1, 2, 1, negative 1. So you can work this out. So 2 into 2 by 2, that is 4, minus 1. Then we have minus minus, that is plus 1. Then you have 2 plus 1, that is 1 times 2 minus negative 1 times negative 1 is just 2 plus 1. Plus 1 into negative 1 minus 2. So it means here we have 2 into 3 plus 1 into 3 plus 1 into negative 3. So we have 6 plus 3 minus 3, which is just 6. So we have that the determinant of the coefficient matrix is 6. So the next thing you're going to look for is the adjoint of the coefficient matrix. So for us to be able to obtain the adjoint of A, we're going to use the cofactors of each and every element in that matrix. So we're going to start with the cofactor of the first element, that is 2. So we take negative 1 and then we raise it to the power, which is given by the sum of the row and the column number. So 2 is in row 1, column 1. So that is 1 plus 1. And then when you cover its row and column, the matrix that is left is 2, negative 1, negative 1, 2. So it means you have, this is positive because the power is even. So we have 2 times 2, that is 4, minus 1, which is just 3. Then we get the cofactor of the next element is negative 1. So we take negative 1. Then negative 1 is in row 1, column 2. So 1 plus 2. Then the small matrix that is left is 1, negative 1, 1, 2. So because this is odd, this will be negative. So we have the negative of 1 times 2, that is 2, plus 1, that is minus minus 1. So that is the same as negative 3. Then we go to the cofactor of the next element, and the next element is 1. So 1 is in row 1, column 3, and the small matrix that is left when you cover its row and column is 1, 2, 1, negative 1. So this is even, the negative will disappear. So you're left with 1 times negative 1, that is minus 1, minus 2 times 1, that is just 2. So we have that to be negative 3. Then we can go to the cofactor of the next element, and the next element is 1. So 1 is in row 2, column 1, and when you cover its row and its column, you're left with negative 1, 1, negative 1, 2. So this is odd, the negative will hold, so we have the negative of, that is negative 2 plus 1. So that is a negative 1 in the bracket, so it means we have positive 1 as the cofactor of that element. Then we also get the cofactor of the other element, which is 2. So the cofactor of 2 will be, you take negative 1. So 2 is in row 2, column 2. So that is 2 plus 2. And when you cover its row and column, you're left with 1, 2, 2, 1, 1, 2. 2, 1, 1, 2. So you can obtain that. This is even, so the negative will disappear. So you're left with 2 by 2 minus 1 by 1. So that is 4 minus 1, and that is 3. And then we go to the cofactor of the next element, that is negative 1. So negative 1 is in row 2, column 3. 2, column 3. When you cover its row and column, you're left with 2, negative 1, 1, negative 1. 2, negative 1, 1, negative 1. So since this is odd, the negative will hold. So we have 2 by that is negative 2 plus 1. Negative 2 plus 1. So that is negative 1 times negative 1, that is just 1. Then we have the cofactor of the next element, and the next element is 1. So you take negative 1. 1 is in row 3, column 1. Row 3, column 1. So that is 3 plus 1. Cover its row and its column, you're left with negative 1, 1, 2, negative 1. So this is even, the negative will disappear. So we have negative 1 times negative 1, that is 1, minus 2. So that is negative 1. Then we also have the cofactor of this negative 1. So you take negative 1. So this negative 1 is in row 3, column 2. 3, column 2. So when you cover its row and its column, you're left with 2, 1, 1, negative 1. 2, 1, 1, negative 1. And since this is odd, the negative will hold. So we have the negative of 2 by negative 1, that is minus 2, minus 1. So that is positive 3. Then finally, we have the cofactor of 2, and 2 is in row 3, column 3. Cover its row and column, you're left with 2, negative 1, 1, 2. So since this is even, the negative will disappear. So you have 4 plus 1, that is 2 by 2 minus negative 1 times 1, which is just 5. So the cofactor matrix is going to be 3, negative 3, negative 3, 3, negative 3, negative 3, and then we have 1, 3, 1, 1, 3, 1, then you have negative 1, 3, 5. So that is the cofactor matrix. So the adjoint of A will just be given by the transpose of the cofactor matrix. So it means the rows become the columns. So let us start with the first one. So the adjoint of A is 3, negative 3, negative 3, 1, 3, 1, negative 1, 3, 5. So now we can obtain the inverse of A by taking 1 over the determinant, which was 6, times the adjoint, that is 3, 1, negative 1, negative 3, 3, 3, negative 3, 1, 5. So if you like, you can open it up, but we can just use it the way it is to multiply B so that we're able to obtain the unknowns. So this therefore means that the unknowns, that is x, y, z, is obtained by taking the inverse of the coefficient matrix 3 over negative 1, negative 3, 3, 3, negative 3, 1, 5, and then multiplying that by the values on the right hand side, that is 1, 4, 1. So we are going to get this to be 1 over 6 into 3 times 1, that is 3, plus 1 times 4, that is 4, plus negative 1 times 1, that is negative 1. Then negative 3 times 1, plus 3 times 4, which is 12, plus 3 times 1, which is just 3. Then here we have negative 3 times 1, that is negative 3, plus 1 times 4, which is just 4, plus 5 times 1, which is just 5. So that will be 1 over 6. In the bracket we have, that is 3 plus 4, that is 7, minus that is 6. And then we have 12. Then here we have 6 again. So if we multiply by this color, that is 1 over 6. So 1 over 6 times 6 will be 1. 1 over 6 times 12 will be 2. And 1 over 6 times 6 will be 1. So we have that x, y, z is equivalent to 1, 2, 1, which just translates to x is equal to 1, y is equal to 2, and z is equal to 1. Example 3, solve 2 over x plus 3 over y minus 1 over z is equal to 10. 1 over x plus 2 over y minus 1 over z is equal to 5. And 2 over x plus 2 over y minus 3 over z is equal to 7 using matrices. So let us see the solution to this. So the best thing to do in this situation is to rewrite the matrix or rewrite the equations. So in this case, you can let 1 over x, 1 over y, and 1 over z be represented by other letters. So you can say let 1 over x be maybe a, then 1 over y be b, and 1 over z be c, so that we can rewrite that equation, those systems of equations, as, so the first one will just be 2 times that is 2a plus 3b minus c is equal to 10. Then the second one will be a plus 2b minus c is equal to 5. Then the other one will be 2a plus 2b minus 3c is equal to 7. So we can solve for a, b, and c, and then we substitute back the values of 1 over x, 1 over y, and 1 over z. So let us start by rewriting these into a matrix. So we're going to have 2, 3, negative 1, 1, 2, negative 1, 2, 2, negative 3. That's the coefficient matrix. Then the unknowns, or the variables, are just a, b, and c, and that is equal to 10, 5, 7. So as usual, we let this one be the matrix A, that the matrix X, and that B. So that to get X, you just have to take the inverse of A times B. And for us to obtain the inverse of A, we need 1 over the determinant of A, then you multiply that by the adjoint of A. So it means, therefore, let us look for the determinant of A. So the determinant of A, we use the first, the elements in the first row. So we're going to take 2, then cover its row and column. You're left with 2, negative 1, 2, negative 3, minus the second element, which is 3, cover its row and column. You're left with 1, negative 1, 2, negative 3, plus the third element, that is negative 1, cover its row and column. You're left with 1, 2, 2, 2. So let us work this out. So we have 2 into negative 6 minus 2, that is plus 2, minus 3 into 1 times negative 3, that is negative 3, plus 2, that is negative 3 minus 2, plus negative 1 into 2 minus 4. So you have 2 into negative 4 minus 3 into negative 1 minus 1 into negative 2. So here you have negative 8 plus 3 plus 2. So that should be negative 3 as the determinant of the coefficient matrix. So we can now obtain the adjoint of matrix A. So we're going to obtain the adjoint using the cofactors. So we're going to start with the cofactor, or the first element. The first element is 2. So we take negative 1. 2 is in row 1, column 1. And the small matrix that is left is 2, negative 1, 2, negative 3. So you can get these to be 2 by that is negative 6, plus 2, which is just negative 4. Then the cofactor of the next element, that is the cofactor of 3, will be given by, so 3 is in row 1, column 2, and the 2 by 2 matrix that is left is 1, negative 1, 2, negative 3. So this is odd, so we're going to have a negative. So negative of negative 3 plus 2. So that is positive 1, because we have, this is negative already, and then in the bracket we have negative 3 plus 2. So that is negative 1 in the bracket, so that is 1. Then the cofactor of negative 1 is in row 1, column 3, and the 2 by 2 matrix is 1, 2, 2, 2. So this will be positive, so we have 2 minus 4, which is just minus 2. Then the cofactor of the next element is 1. So 1 is in row 2, column 1. Cover its row and column, you're left with 3, negative 1, 2, negative 3. 3, negative 1, 2, negative 3. So this will be negative. So we have negative 9 plus 2. So we have negative 7 times negative 1, that is 7. Then the next one, and the next element is 2. So 2 is in row 2, column 2. Cover its row and column, you're left with 2, negative 1, and 2, negative 3. So this is even, so that is positive. So we have negative 6 plus 2, which is just negative 4. Then the cofactor of the next element is negative 1. So negative 1 is in row 2, column 3. 2, 3. Cover its row and column, you're left with 2, 3, 2, 2. 2, 3, 2, 2. So this is odd, so we're going to have a negative there. That is 4 minus 6, which is just positive 2. Then the cofactor of 2, which is the next element. So 2 is in row 3, column 1. And then the 2 by 2 matrix that is left is 3, negative 1, 2, negative 1. So this is even, that will be positive. So we have 3 times negative 1, that is negative 3, plus 2, that is negative 1. And the cofactor of the next element, which is 2. 2 is in row 3, column 2. Cover its row and its column, you're left with 2, negative 1, 1, negative 1. 2, negative 1, 1, negative 1. So this is odd, we are going to have a negative. So negative of negative 2 plus 1. So in the bracket we have negative 1 times that negative, that will be positive 1. And finally we have the cofactor of negative 3. So negative 3 is in row 3, column 3, and the small matrix that is left is 2, 3, 1, 2. So this is even, that will be positive. So we have 2 times 2, which is 4, minus 3, which is just 1. So the cofactor matrix will be given by negative 4, 1, negative 2, 7, negative 4, 2, negative 1, 1, 1. So now the adjoint of A is going to be the transpose of this cofactor matrix. So you want to have negative 4, 1, negative 2, 7, negative 4, 2, negative 1, 1, 1 as the adjoint of A. Now we have the determinant of A. we have the determinant of A as -3, and we also have the adjoint of A as -4, 7, -1, 1, -4, 1, -2, 2, 1. So we can now use this information to obtain the inverse of A. We take 1 over the determinant of A times the matrix -4, 7, -1, 1, -4, 1, -2, 2, 1. So that is the inverse. We can now obtain the unknowns, that is A, B, and C, by pre-multiplying what we had on the left hand side, on the right hand side, by this particular inverse. So just check, that is now -1/3 into -4, 7, -1, 1, -4, 1, -2, 2, 1 times what we had on the right hand side. That was the results. It was 10, 5, and 7. So we can multiply these two matrices first, then we multiply by the scalar there. So we're going to have -4 times 10, which is just -40, plus 7 times 5, which is 35, plus -1 times 7, which is just -7. Then we have 1 times 10, which is 10, minus 4 times 5, or plus -4 times 5, that is -20, plus 1 times 7, which is just 7. Then you have -2 times 10, that is -20, plus 2 times 5, which is 10. Then you have plus 1 times 7, which is just 7. So that is the product of the two matrices, but we multiply by the scalar -1/3. So you can work out this. So you have -1/3 into, if you take that, you're going to have -5, negative, that will be -12. And here we have -17. Is it -17? You have 10 plus 7, that is 17, minus 20, that is -3. And down here we have 10 plus that is 17, minus that, another -3. So if we simplify this, we're going to have -1/3 times 12, that is +4. Then we have +1 and +1. So those are the values of A, B, and C. But remember, initially when we started, we were dealing with 1/x, 1/y, and 1/z. So we had said that we were letting 1/x be A, 1/y was B, and 1/z was C. So now that we have that the value of A is 4, the value of B is 1, and the value of C is 1, we can use that information here. So we have A is 1/x. So it means therefore that 1/x is equal to A, and A is 4. So this implies that x is equal to 1/4, and then we have 1/y is equal to B, and B is 1. So this means that y is equal to 1/1, which is just 1, and the other one is 1/z is equal to C, and C is also 1. So it means therefore that Z is also equal to 1. So those are the values of x, y, and C. Now you can attempt some 2 questions and see if you have mastered the arts that we have shown there. So kindly try. The first one is solve 3/x plus 6/y minus 3/z is equal to 5, and 2/x plus 2/y plus 3/z is equal to 4, and 1/x minus 4/y plus 6/z is equal to 1. And you're required to use matrices, of course. Then the second one is x minus 2y plus z is equal to 1, and the 2x minus z is equal to 3, and x plus y plus 2z is equal to 4 using matrices. So do that and leave your answers in the comment section, and please subscribe to my channel so that whenever I post a video you get notified. And thank you for watching.